Today's lecture will be on fractional knapsack. So we already discussed in our previous lecture of 0-1 knapsack that 0-1 knapsack was based on the dynamic approach. Fractional knapsack is based upon the greedy approach. So what is the scenario? What is our data input? The values that we are given or the scenario that is given is the same. The knapsack maximum capacity is 50 kg and there are 5 items to choose from of the 10, 15, 20, 25 and 30 kgs with the values of $60, $70, $80, $90 and $110 respectively, right? And we cannot take an item twice. We can only take an item once. But fractional knapsack problem gives us the additional advantage that we can take fractions from a weight, fractions from an item to fill up our bag to maximize our bag to 50 kg along with maximized value. The formula summation xi wi should be less than w max, that is our restraint, but wi in this particular formula can also be replaced by vi as in value. Okay, the other thing, the value of x should be 0, should be less than 1 and greater than 0, but should inclusively, that is 0 is less than equal to x is less than equal to 1. Now what we need to do is place all these values in a table. So we place it in the table such that we name the items as item A, B, C, D and E value with the weights of 10 kg, 15 kg, 25 kg, 20 kg, 25 kg and 30 kg respectively, and their corresponding values 60, 70, 80, 90 and 110. The feature, different feature from the 0-1 knapsack is that in fractional knapsack we sort it with respect to ratio. So first we find out the ratios. Ratio as in V upon I, that is if 10 kg has a value of $60, what is the value of 1 kg? The ratio will find out that is one portion, okay. So 6 upon 1 will give you 60 upon 10 will give you 6. The ratio is 6. The ratio for item number B is 4.66. The ratio for item number C is 4. The ratio for item number 3 is 3.6. The ratio for item E is 3.66. We have calculated all the ratios, and also we will denote A as x1, B as x2, C as x3, D as x4 and E as x5. After that we need to sort the table with respect to the ratios in descending order, that is from the highest to the lowest, and rearrange them. So once we rearrange them, we can see that A, B and C items are in the same place, but E and D have swapped places since the ratio of E is greater than the ratio of D, right? So now let's start filling up the bag. Let's start filling up the knapsack. We know that the maximum capacity the knapsack can hold is 50 kg. So item A, full 10 kg we can place. So x1 is equal to 1, which is the maximum value. We place it over there. X2, that is B, 15 kg will be added. So x2, whole of x2 can be placed over there. That is now 25 kg. What about C? C is 20 kg. So 25 plus 20 is equal to 45. We can place the entire C over there. So x3 is also 1. Fine. Then we come to the value E, item E. Item E, 30 kg can no longer be placed in the bag because the bag is already full with 45 kg. You can only place 5 kg over there. So from 30 kg, we will extract only 5 kg. So 5 kg from 30 kg is what? Is 1/6 of the portion, right? 5 6 are 30. So 1/6 of the portion of 30 is 5 kg, and that is all we need. So x5 is equal to 1 upon 6, that is 5 kg, so that our bag is maximized up to 50 kg. What about item D? Our bag is full. So we no longer have space. So x4 is equal to 0. Now place it in the formula. X1 xivi summation, we just add them. X1 into V1 plus X2 into V2 plus X3 into V3 plus X4 into V4 plus X5 into V5. We place the corresponding values, and you can see that 1 into 60, 1 into 70, 1 into 80, 0 into 90. Why? Because the x4 is item number D and we did not place any portion of item D in our bag, so it is 0. x5 is 1 upon 6, 1 upon 6 into 110. So we have the summation, we got the value $228.37. That is the maximized output that we can obtain from using fractional knapsack. Okay, so how do we know it is better than 0 1 knapsack? How do we know the 0 1 knapsack was better? We have already discussed 0 1 knapsack with another example in one of our previous videos, but for the sake of comparison we will take these values and compare them to the 0 1 knapsack, right? So 0 1 knapsack, we know, either takes the whole item or doesn't take it. This is the formula using dynamic programming that we use to solve it, and this is the entire table that can be generated by the method. You can see the video of 0 1 knapsack how this whole table is generated, right? And using the formula we can find out the maximum value, that is row 5, I5 and 50 kg, and we get what? We get 220 dollars. So the maximum that 0 knapsack can achieve in this case with this data is $220, but fractional knapsack gives us $228.37. Hence, in this scenario, greedy approach wins the dynamic programming paradigm. Okay, fractional knapsack gives us better output as compared to 0 1 knapsack in this particular case. That's it. I hope you liked the video. Kindly subscribe and click like. Thank you very much.